Recycling Methods for Thermosets by Patrick Hardy. The presentation will be over thermosetting materials, the age of plastics, recyclable thermosets, and green plastics. Thermosetting materials first came to the United States market in 1869. The first material was known as celluloid, which was used to replace elephant ivory in billiard balls. Thermosets are defined as a resin in a soft solid or viscous state that changes irreversibly into an insoluble polymer network by curing. Curing, which can be induced by heat, radiation, or both, transforms the resin into a solid by a cross-linking process. Once cured, a thermoset cannot be melted or reshaped, so therefore they cannot be recycled. However, thermosets are needed in the United States market because they are better resistant to high temperatures, usually more flexible, and have a higher dimensional stability than in thermoplastics. 18.2 billion pounds of plastic has been produced since the 1950s. Plastics are made from petroleum oil, a non-renewable resource. Lots of plastic is littered into our environment each day. 8 million tons of plastic enter the oceans each year. The accumulation of plastic in the ocean is known as the Great Pacific Garbage Patch. The pollutants from the littered plastic are playing their way up the food line all the way to top-level predators. Living in the age of plastics means the plastic industry has a very large role in the sustainability of Earth's resources. Earth's resources have never been more crucial than now, and actions of plastics manufacturers can make a real difference. Researchers at IBM in the United States stumbled upon two new classes of thermosetting materials that are able to be recycled. They introduced carbon nanotubes in specific materials which could then be broken down by strong acids. Once broken down, the monomers were recovered and then polymerized to make new products. The main material IBM researched was polyhexahydrotriazine, or PHT, which is one of the strongest thermosetting materials, and it was made even stronger with the introduction of carbon nanotubes. The polymerization process used the reaction of amines and paraformaldehyde. Paraformaldehyde is used in the manufacturing of thermoset materials, so this method could easily be used on a wider scale with facilities and equipment already in the industry. Researchers also stumbled upon a new elastic gel with self-healing properties called elastic organogel. The product can withstand physical damage and, if damaged, could heal itself back to original form. These new thermosets could replace existing ones in applications like electronic devices, as well as applications in the automotive and aerospace industries. Green plastics has been a new fad in the plastic industry within the last few years. One of the newest green plastics is made from soybean oil. Manufacturers can produce soy polyols in a wide range of applications, including automotive foam and bedding foam. Soy-based resins have a bunch of positives, including the enhancement of the sustainable profile of specialty elastomers, coatings, and adhesives. They also provide enhanced chemical, and corrosion resistance compared to regular polyols. The need for soy-based thermosets is to displace the use of crude oil in materials. Soy polyols have lower carbon dioxide emissions and energy costs during production. Research continues to grow for soybean oil-based plastics. Possibilities are growing and applications could be endless for green plastics.